Welcome to GR Hub Mathematics and Statistics lessons. Today I'm going to be talking about Surds part 5, where we shall be considering rationalization of surds. Now I'm going to cut the long story short. What do we mean by rationalization of surds? There are two ways surds can be expressed in quotient. So in the first one, the denominator could be a surd, or in the second, the denominator may not be a surd and the numerator is a surd. So which one is really our concern when it concerns rationalization of surds? It is the first one. When surds are expressed in quotient, and in particular their denominator is a surd, that kind of surd must be rationalized. So rationalization is the process of transforming a surd in quotient form whose denominator in particular is a surd. Okay, so we are going to show you in this video how to rationalize surds. But the first thing I want you to understand is that surds can be expressed as quotients. Story number one. Two, surds when expressed as quotients may appear in two forms. Story number two. Okay, you get that right. Now, the third thing is this: when surds appear as quotients in any of these two forms, which one are we rationalizing? Which one really demands the technique of rationalization? It is the one out of the two quotient forms of a surd that has its denominator to be a surd itself. So rationalization is simply a technique of transforming a surd in its quotient form whose denominator is a surd itself to a surd still in its quotient form whose denominator is not a surd. So now these are the two forms we shall be considering, this form and this form. Now the second form here is not of much concern because it needs no rationalization. Why? The denominator of this surd, which is expressed in quotient form, happens to be a rational number. But in this case, the denominator is a surd. Do you see it? So the denominator is a surd. It is the root of n. So surds in quotient forms like this need to be rationalized simply because their denominators are surds. Now, the question is this: how then do we get that done? Okay, so the latter in this case poses no problem, no computational challenge, but the former poses a computational challenge, and this is our interest. When we rationalize or say we are rationalizing surds, we are concerned with transforming a surd in its quotient form whose denominator in particular is a surd. Okay, so now what is the technique all about? How do we rationalize surds? To rationalize surds simply means making its denominator a rational number. How do you get that done? To do that is simple. All you have to do is to multiply the numerator and denominator of that surd by the surd in the denominator. That's all. So I'm going to give you an example. Let me just repeat that statement just in case you did not get me. To rationalize a surd in this form simply requires that you multiply its numerator and denominator by the surd itself. Okay, so that is what you do to rationalize a surd in this form. Now, coming over here, you would notice that there is another form in which a surd in quotient form can appear. A surd in quotient form can appear in this manner, and it also requires that you rationalize it. Again, rationalization simply means a surd in its quotient form having its denominator to be a surd. Okay, so the process of rationalization ensures that a surd in its quotient form having its denominator to be a surd is no longer in a quotient form having that denominator as a surd. So all you have to do in this case, if it appears in this manner, is to multiply the numerator and denominator by the conjugate of that denominator. If you don't know what we are saying about conjugates, please refer to our video on conjugate surds. Okay, so all you have to do when a surd appears in this manner, such that its denominator is of the form root a plus root b, or of this form, all you have to do is to multiply the numerator of that sod and the denominator by the conjugate of the denominator, and that will put the sod straightway in a rational form. Okay, so that being said, let us consider the following examples quickly. So for example, to rationalize this sod requires that I multiply the numerator and denominator by the sod in the denominator. What is the sod in the denominator? The sod in the denominator is root 5. So I'm going to multiply root 5. I'm going to multiply 3 being the numerator and root 5 being the denominator by root 5 and root 5. Okay, why am I multiplying the numerator and denominator by root 5? It's because I want to rationalize. So that gives you, for the numerator, 3 root 5, and for the denominator, root 5 times root 5 will give you 5. So that's coming from indices. Okay, remember, from indices, root 5 can be written as 5 raised to the power half, and this root 5 can also be written as 5 raised to the power half. So 5 raised to the power half multiplied by 5 raised to the power half gives you, by the law of addition in indices, 5 raised to the power half plus half, which is 5 raised to the power 1, and 5 raised to the power 1 is 5. Okay, so if you consider the next example, you will notice that, again, I'm particular about this example anyway, because 2 over 3 root 5 has been given to you to rationalize. Clearly, it needs rationalization. Why does it need rationalization? It's because the denominator has a sod. Do you see it? So, since the denominator has a sod, this sod as a whole needs to be rationalized. And how do you rationalize it? Students often make the mistake of using the whole denominator to multiply the numerator and denominator just to rationalize. You don't have to stress yourself. It boils down to the same thing. All you have to do is to multiply the numerator and denominator by the sod itself, and the sod in this case is root 5. Okay, so to get that sod, 2 over 3 root 5 rationalized, all I have to do is to multiply the numerator and denominator by root 5, and that simply gives 2 root 5 in the numerator and 3 times 5. Now, how did I get 3 times 5? That is root 5 times root 5, like we explained earlier, gives 5. Then multiply it by 3, that gives you 15, and the result becomes 2 root 5 over 15. Now notice this sod, 2 root 5 over 15, is now rationalized. Why is it rationalized? It is simply because the denominator is no more a sod. So making a sod rationalized simply means making its denominator no more a sod. Okay, now let's consider the second form I told you. Sods could appear in quotient form. So when a sod appears in this manner, for you to it also needs rationalization, and I'm emphasizing it needs rationalization simply because the denominator contains a sod. So rationalization is the process of eliminating a sod from the denominator of a sod when expressed in quotient form. So all you have to do in this case is to multiply the numerator and denominator by the conjugates. So the conjugate of 2 minus root 5 is 2 plus root 5. So use 2 plus root 5 to multiply the numerator and denominator of this sod, and that will give you 3 in bracket 2 plus root 5 in the numerator and 2 square minus root 5 square. If you remember what we discussed on difference of 2 squares, this would amount to difference of 2 squares. So all you have to do is to say 2 squared minus root 5 all squared, and 2 squared gives you 4, root 5 squared gives you 5, and that becomes, when you expand the numerator, 6 plus 3 root 5 divided by 4 minus 5. Now 4 minus 5 simplifies to minus 1. So that gives you minus in bracket 6 plus 3 root 5 divided by 1, which is the same as minus 6 minus 3 root 5. Of course, minus multiplies 6 when it opens the bracket to give you minus 6, and minus multiplies 3 root 5 to give you minus 3 root 5. Okay, now that being said, let us consider a final example on that, and you will notice, to rationalize this sod, 2 over root 5 plus root 3 simply implies multiplying the numerator and denominator of that sod by the conjugate. What is the conjugate of root 5 plus root 3? It is root 5 minus root 3. So for me to rationalize this, I need to multiply the denominator and numerator by the conjugate of the denominator here, which is the sod. So If you multiply by the conjugate, it gives you, for the numerator, 2 in bracket root 5 minus root 3, and for the denominator, by difference of 2 squares, root 5 squared minus root 3 squared. Now that simplifies to, for the denominator, 5 minus 3, because root 5 squared is 5 and root 3 squared is 3. So for the numerator, when the bracket is expanded or open, it gives you 2 root 5 minus 2 root 3. So that simplifies to 2 root 5 minus 2 root 3 all over 2. And factorizing again brings out 2 in the numerator. And when that 2 is divided by 2 in the denominator, it ends up giving you root 5 minus root 3. Now, I want you to try this and drop comments below, okay? Try the following. Try rationalizing all these I've given to you and drop your comments below. Tell us what you encountered when solving the problem, and we'll see you in our next class on Surds. Do like our videos, share our videos, make comments, good comments, criticize our videos, and most importantly, please, please, and please subscribe to our YouTube channel. Thank you very much.